Hello, students. We were busy with the partial integration and substitution, and I told to you in the video before this one that I would do some examples. Yeah, and walking to the from the station to here, I asked myself, what shall I do? Now, maybe the first one is a nice one, is this one here. X times the arctangent of x, and I want to have the primitive function of it about what to do. Now, what do I see? I have no idea for some primitive function. I have no idea. Substitution. No, I should not know what to do because I think it becomes not easier. And then I think that partial integration is maybe some way to do. So I think that you can do this with partial integration. But what then? Now, from the arctangent, I don't know the primitive function. I have no idea. So what can be the only way to do then in certain sense is that this becomes a derivative and this is your g. And then we are going to do partial integration. So you have brackets open and then we have f times g. Now the primitive function of x becomes 1 over 2x squared, and now you get the arctangent of x. It looks that it becomes not easier, but maybe. And then we have minus the integral, and then you have f times the derivative of g. Now the f that was x squared divided by 2, and we have the derivative of the arctangent that we know that is 1 divided by 1 plus x squared dx. Now and then, yes, what then? So here I have done the partial integration steps, no problem. And then I see here, I see an x square and I see there an x square. Maybe we can use that on some way. So what to do? Now we have in the brackets, we can nothing make easier or so. So you have x squared divided by 2 times the arctangent, and then minus the integral of, and what can we then do? Maybe we can add 1 and subtract 1. So in certain sense, nothing do. So this one here, x squared plus 1 minus 1 divided by 1 plus x squared dx. So in certain sense, I have nothing changed. I have only done plus 1 minus 1. Why? Now, if you divide these together, you get 1, and the primitive of 1 is no problem. And if you divide the other two, 1 the minus 1 and 1 plus x squared, I see that you get the derivative of the arctangent back. And yes, we can do that. Then we get some primitive function out of it. So we get x squared divided by 2 times the arctangent that we have still between the brackets. And then we have minus and then 1 over 2. I put before the integral, and then I have 1 and then minus 1 divided by 1 plus x squared dx. So by that plus 1 and minus 1, I can write down something easier. And what do I get out? What I get out of it as a result? Now between the brackets we have still that x squared divided by 2 times arctangent, and then be careful with your multiplications. You have minus 1 over 2 times 1, so if I integrate that I get minus 1 over 2 times x. And then we have also, and that I mean with be careful, you have also minus 1 over 2 times that one, but be careful with your minus sign, so you get plus, and so you have the primitive function of the arctangent, so you get there 1 over 2 times the arctangent of x. And I think here I have my primitive function, and we can let away the brackets away. We have no integrals anymore. And then be careful, don't forget your c. And here you have your primitive function of that one, of the first one, x times the arctangent. We have here the primitive function. And so you see, you can try something, you can do something, and then, yeah, by trying, you get something. And then, what then? I I was asking myself if I have some. Oh yes, that's what I also. I thought to myself when I walked to here to my room. Um, can we do the cosine squared x? Can we do that also by partial integration? That was that I asked myself. And yeah, what then? Yeah, cosine squared, that means cosine x times cosine x dx. And then I want to do it by partial integration. Now, so I can choose one of the two as the derivative and the other one as g. And so we have between the brackets. Now, if you have the derivative of f, if that is the cosine of x, then the primitive of it becomes the sine. So we get sine of x times the cosine of x. So here you have your f and here you have your g. That's between the brackets, and then minus the integral, and then you have f times the derivative of g. And so the f that was the sine of x, and the derivative of the cosine is minus the sine of x. So we have then plus, and then we have again the sine of x dx. And then most people will think, no, we are not further anymore because you have there sine squared, and then we have to do something with that. But what can we use? We know cosine squared plus sine squared becomes equal to 1, and so we can write sine squared as 1 minus the cosine squared. And so what do I get? What's the result? Now then I started with the cosine squared. That was the first, and then I did some steps. I have between the brackets, I have the sine of x times the cosine of x, and then I have that integral, and then plus the integral, and then sine squared is 1 minus the cosine squared dx. And look, what do I have? You have now between the brackets still sine x times the cosine of x. Then we have plus, and then c, you have your primitive function of 1, and that becomes equal to x. So we can write here down for the brackets the first sine x times cos, and then we have plus x, and then we have minus the integral of cosine squared dx. And then look, here we have plus the cosine squared, and here we have minus the cosine squared. So I can throw one of the, I can throw this part here from the left hand side, I can from the right hand side, I can throw to the other side of the equal sign. And so what do we get out of it? We get 2 times cosine squared dx becomes equal to x plus, and then sine x times cosine x between those brackets. Now, and then I asked myself the question was the primitive function of cosine squared. And so we can write down 1 over 2 times x plus, and then we have sine x times cosine x plus some constant. And so we have also calculated the primitive function of cosine squared without using those formulas for the cosine of 2x and sine of 2x. So this is also some way of working. And what do I see here? Here I see almost the what is that? That is equal to 1 over 2 times the sine of 2x. And so we have, if you go further on, you have 1 over 2 times x, and then plus 1 over 4 times the sine of 2x plus some constant. Now, and here you have also, we have at this way, we have also calculated the primitive function of the cosine squared, but then with partial integration. So this is also some way to calculate that, and so you can also do that with the sine squared. And you can also use partial integration, and you can use it on the same way. And yeah, what is the nice thing of it is that you have here your plus sign, and here you have the minus, and that you therefore you can throw one of those integrals to the other side of the equal sign, and you can write it out. Okay, so this is also some way. And then I would use yes, I should like to do some example where you have to use the you have used to use the the substitution and the partial integration. And that what I want to do is this one here, the integral from 0 to 1, and then 4 minus x squared, taking the square root of it, dx, and then how to solve this one. Now here, really I have no idea directly from what I can do. So what could we do? Now, I am thinking, and then if there should be, if you have 1 minus x squared, then maybe you can fill in a cosine or a sine of x. And so maybe we can do the following, that we take for the x 2 times the cosine of phi. Or what we can also do is the sine of phi. That's what shall I do? No, maybe that it doesn't matter me, but I will do the sine of phi. Why, I don't know, but I like this one here. So then you have 4 minus x squared. If you fill in, you get 4 minus 4 times sine squared, taking the square root of it, and we get out of it 2 times the square root of cosine squared, and this one will give you 2 times the absolute value of the cosine of phi. Now, yes, what do we see? The phi, do we have some can we let the brackets away or not? I have no idea. For instance, if x is 0, then you see that you get 2 times the sine of phi is equal to 0. And so you can take for your phi 0. And if your x is equal to 1, what do we have then? Then you have that 2 times the sine of phi has to be equal to 1. So the sine of phi has to be equal to 1 over 2. And we can take for the phi, in this case, pi divided by 3. Pi divided by 6. And you have, let me see, you have here the unit circle, and you have that the angle is 0, and you have that the sine of that angle has to be equal to 1 over 2. And you see that you have here that angle pi divided by 6. And so, and if the angle is between 0 and pi divided by 6, the cosine is positive, no problems. And so we can let that absolute value away. So we can here write down 2 times the cosine of phi. So here you see that the phi between 0 and pi divided by 6. And what I told to you just a few minutes ago was that the cosine of phi is positive. And so you can let that absolute value away. Okay, so we have now rewritten that 4 minus x squared, the square root of it becomes 2 times the cosine of phi that we have. And then we want to substitute. Now, so I have also to calculate the dx term. Now I can differentiate x to the phi, and if I differentiate it to the phi, I get 2 times the cosine of phi, and so you see that the dx becomes equal to 2 times cosine phi times d phi. So we have now the substitution. We have some expression for the square root. We have just calculated the dx term, and we have also the boundaries of that integral. And now let's see. I will write that integral again. This one here. And what do we have? Now, if x is 0, the lower boundary, then the phi becomes 0. Okay, if x is 1, the upper boundary, then the phi becomes pi divided by 6. All right, we have 4 minus x squared. We have rewritten in some expression, and we have just calculated that is 2 times cosine phi. And we have just calculated the dx term, and that becomes also something with a cosine, so 2 times cosine phi d phi. And here we have that integral from 0 to pi divided by 6. I see 2 times 2 is 4, so I can put 4 before the integral, and I have cosine squared phi d phi. Now, we have just calculated the primitive function of cosine squared. Here you see. And so what do we get out of it we have some brackets open, and then we have 4 times, and then I have to look for it. I can't remember it. Here I have my I will copy it, and then I will do paste, edit, paste this one here. But be careful with the variables. We are using phi as the integration variable, so we have to do this one here. Okay, this is the primitive function. And you know, if you fill in an upper bound and a lower bound, the constant c falls away, so that we have not to write down here. And we have this expression. And does what does it give to us? It gives us 4 times, and then we have pi divided by 12, and we have plus 1 over 4 times the sine of pi divided by 3. That is the upper bound I have filled in, and then the lower bound I have to subtract, so I get 1 over 2 times 0 plus 1 over 4 times the sine of 0. No, that is that I could have I could directly put down there 0. Okay, and so what does it give as a result? Pi divided by 3, and be careful with the calculations. 4 times this one, 4 times that one, and then we have 4 times the other one gives the sine of pi divided by 3, and the sine of pi divided by 3 is 1 over 2 times the square root of 3. And here I have my result of that integral. And then you see, first I have done some substitution. This part is the substitution. And this one here with the cosine squared, you could do it by partial integration, we have just seen. And that gives us some result. Okay. Now, what then? Now, maybe again some example where I have to use the substitution and the partial integration, but maybe now first the partial integration and then the substitution. Now, for instance, asked to me is the primitive function of the arc sine of x. Now, some people don't, I don't know, I really don't know, but I know the derivative of the arc sine, I know, so maybe we can do the following, that we can write down this integral as 1 times the arc sine of x, and then that 1 we take as the derivative, and the arc sine as the g, and we do the partial integration. Now, what do we get out of it? We have to calculate f times g, so between the brackets, so this becomes x times the arc sine of x, and then we have minus the integral of, and then we have f times the derivative of g. Now ft was x, and the derivative of the arc sine I have also that becomes equal to 1 divided by 1 minus x squared, and taking the square root of it, dx. Okay, and then we can go on. So we have between the brackets x times the arc sine of x, and we have minus the integral of x divided by 1 minus x squared dx. Now, if you don't see directly from the second integral what to do, then you can there maybe use partial integration, of not partial integration, substitution. For instance, that you say, I take u equal to 1 minus x squared or something like that. And then the du becomes minus 2x dx, and you see that you have your term x dx, and I have here also x dx, so I can that write is in du, and the square root of 1 minus x squared becomes equal to the square root of u. And but maybe other people see directly the primitive function of that integral. So you have x times the arc sine of x, and then what will be the primitive function? I think it will be something of the square root of 1 minus x squared. If I differentiate this one, you have to the power 1 over 2, that 1 over power 1 over 2 comes before, and then you have to subtract 1 of the power, and you are dividing by the square root, because you get to the power minus 1 over 2, and we have to multiply by the term by the derivative of 1 minus x squared, and that gives you minus 2x dx. Okay, and that is okay, so we have plus this one plus derivative of c. So, so you can also do it directly. You can also do some substitution. If you see directly the primitive function, you can write it down, but be careful with all those constants in this case, but here it goes well. You have that 1 minus x squared. You write here you have to calculate the derivative of it, and that means the derivative of 1 minus x squared to the power of 1 over 2, and so we have 1 over 2 times 1 minus x squared. You subtract 1 and you get minus that one, and you have to take times the derivative of 1 minus x squared, and so you see that you get minus 2x divided by 2 times 1 divided by 1 minus x squared, taking the square root of it, and we have minus x divided by that square root, and that gives you exactly the primitive function you need, because you have minus here and you have x times that term of x divided by the square root of 1 minus x squared, and you see here the same back. And so you see that you can also calculate the primitive function. And yeah, what is the nice step here? In certain sense, that put 1 before and try to do something with it, and hopefully you get something with what you can do. Yes, that is, you never know. You're always, you have to try and then look if it goes well or not. Okay, here we have done some examples. Maybe I can do also some other examples. Um, but we have not so much time at this moment. And I mean that I have already 30 minutes and the file has not to become too large. Um, okay, no. Let's see the next video. I want to do some other examples.